A moment of wonder. Look at this. Millions of bright red cranberries blanketing the surface of a flooded field, stretching as far as the eye can see. Seeing these massive crimson lakes every autumn, it is incredibly easy to assume that cranberries are aquatic plants, growing naturally underwater like kelp or water lilies. But that image is an illusion. Cranberries actually grow in dry, sandy soil. They thrive on low-lying, tangled, woody vines that creep tightly along the ground. For generations, farmers had to harvest these fields completely dry. That meant crawling on hands and knees, combing through stubborn vines to pluck off tiny berries one by one. A slow, exhausting, and heavily labor-intensive process. So if this fruit lives entirely on dry land, why do modern farmers deliberately pump millions of gallons of water over their crops right before harvest time? The answer is that the flood has nothing to do with how the plant grows. It is a brilliant agricultural hack designed to exploit the natural physics of the berry itself. To understand this, we must look inside. Slice a ripe cranberry perfectly in half, and you reveal exactly what makes the harvest possible. Right in the center, surrounding the seeds, are 4 distinct hollow chambers. Botanists call these empty spaces locules. These hollow pockets developed because cranberries evolved in wild wetland environments. The locules act as natural rafts, allowing the seeds to float away and disperse when the surrounding bogs naturally flood. By trapping empty air inside a relatively large outer shell, those 4 locules drastically lower the overall mass-to-volume ratio of the fruit. This schematic compares a cranberry's density against fresh water. Because water has a higher density, the math dictates the fruit simply cannot sink. According to Archimedes' principle, pushing the berry underwater displaces water that pushes back, exerting a constant upward buoyant force. Long before humans ever started farming these vines, every single cranberry was already biologically engineered as a miniature flotation device, waiting for water. Back out in the massive agricultural bogs, pumping in millions of gallons of water is only step 1 of the harvest. Even though the buoyant force is pulling the berries toward the surface, they remain stubbornly anchored to the submerged vines by thick, tough stems. To break that grip, farmers drive specialized tractors through the flooded bogs, pulling heavy mechanical threshers, affectionately known as water reels. The water reels churn the surface, sending a violent horizontal current to test the tensile strength of the stems. When mechanical force overwhelms the stem, the connection fails. The downward anchor is gone, and the fruit's internal air immediately takes over. Multiply that tiny snap by billions, and you get a massive chain reaction as an entire crop detaches and rockets to the surface at once. The modern wet harvest relies entirely on this partnership. Farmers apply violent mechanical force to break the physical anchor and rely on gentle fluid dynamics to deliver the crops straight to their nets. When growers widely adopted this flooding and threshing technique in the 1960s, crop yields spiked and labor times plummeted. By leveraging buoyancy instead of human hands, farms scaled up their operations exponentially. The cranberry went from a minor, hand-picked seasonal novelty to a heavily industrialized agricultural staple. Today, thanks to the sheer volume of fruit that can be collected using the wet harvest, the global market for cranberry juices, dried snacks, and sauces sits at a multi-billion-dollar valuation. So when you look back out over these millions of floating berries, you are seeing physics operating on a massive commercial scale. The entire sprawling spectacle of the global cranberry trade rests entirely on 4 microscopic pockets of empty space.